All right, welcome back. This is going to be part 2 of Quad 3, factoring quadratics, or solving quadratics using factoring methods. What we just finished up here is we just finished 2 factoring methods. We did the difference of perfect squares and product and sum factoring. Well, product and sum factoring was when a was 1, when we have ax squared plus bx plus c. So it's just x squared plus bx plus c. And now we need to do this. We need to figure this out when a isn't 1. When a isn't 1. We have this method, and I think it's really, really cool. And it's a lot better than trying so many of the other methods that we've got. What we're going to do is call this slide and divide. It is extremely versatile. Let's take a look at what this is. Here's what we've got, the slide and divide method. When a is not 1. When a is not 1. Okay. This is our example, right? We've got 2x squared minus 5x plus 1. What we're going to do is the slide. We're going to slide the leading coefficient, slide a, and multiply the last value. What we're going to do is write it as if it's a product sum. In other words, we're going to write it so it's just x squared minus 5x plus 4. Because we slid that 2 over, and 2 times 2 is 4. Now we're going to follow the same rules as we just did before. What multiplies to 4, positive 4, but adds to negative 5? Well, that's negative 4 and negative 1. So we end up with x minus 4 times x minus 1. There we go. Okay, we knew how to do that. That's cool. That's cool. Now we've done the slide part. Now we need to do the divide part. That number that you slid over, always have that in mind. That 2 that we slid over, now we're going to divide it to both constants. We're going to divide the negative 4 by 2 and then negative 1 by 2. Now, lots of nows. We're going to simplify those fractions if we can. Does negative 4/2 simplifies? It sure does. It simplifies to negative 2. But negative half doesn't simplify any further than that. It doesn't simplify any further than that. So what we're going to do, we're going to kick this denominator up in front of that variable. In other words, we're going to make it look like 2x minus 1 instead of x minus half. And what's really neat is if you multiply these two things together, guess what you would get? 2x squared minus 5x plus 2. You would. You totally get that. I know. It's a lot. Let's take a look. We're going to do one together here. 3x squared plus x minus 2. I know it's there, but we're going to do it together. I'm going to slide this 3 down to the end to get x squared plus x minus 18. Remember, 3 is what we slid down. Oh, I'm sorry, 6. I'm trying to multiply this one. Minus 6. What multiplies to negative 6, but adds to, again, if it's just plain x, that's like 1x. So what multiplies to negative 6, but adds to positive 1? Well, that's positive 3 and negative 2. In other words, we have x plus 3 times x minus 2. Now that number that we slid to begin with was 3. Divide both coefficients by 3. Can we simplify these fractions? Yes, we can, because x, so 3/3 here, that's just 1. Can we simplify negative 2/3 any further? No, we can't. We're going to take that denominator and kick it up to the front and make this 3x minus 2. This is our factored form. This is our factored form. This was so cool the first time I saw this, because I've been working on so many different methods to help people out. How do we remember this method and this method and this method? And this slide and divide method works for all of them. It even works for, I don't know, difference of 2 squares. It even works for basic factoring or product sum factoring because of the nature of it. If I was doing basic factoring when a is 1, I'm just sliding 1 down. I'm just sliding 1 down. All right. Use this. Use these steps. because we've got a couple examples. I'm going to do the first one and I want you to do the second one. I take that back. I'm going to do the second one. I want you guys to do the first one. I have 2x squared minus x minus 1. Like we said, our first thing to do is slide this down and multiply to give ourselves x squared minus x minus 2. I took the easy one. It's okay. Now we need to do just like we do product sum factoring or basic factoring. And we say that what multiplies to -2 adds to -1. This is like x minus 2 times x plus 1. Sure is, because -2 times 1 is -2 and -2 plus 1 is -1. So we've done our slide, we've done our basic factoring, our product sum factoring, and now we need to do the divide. What did we slide down? We slid down 2. So now we need to divide both our constants by 2. Can we simplify this one? On the left, x minus 2 halves, we can. It's x minus 1. Can we simplify x plus half? Half does not simplify any further. We're going to kick that denominator up in front of our variable. 2. There we go, 2x plus 1. 2x plus 1. So excited. This is factored form, and hang on to this factored form. Hang on to this factored form. After you do this example, we're going to talk about, well, what have we been doing the whole time? We haven't been solving anything. There's no equal signs yet. Try that. Try 5x squared minus 17x plus 12, and then come back when you're done. Okay, now that you're back, here we go. Slide, the slide part. Take that 5, slide it down to the end, multiply it. I end up with x squared minus 17x plus 60. Ooh. I'm trying to say to myself, what multiplies to 60 but adds to -17? When I tell myself that, I know 5 times 12. That gives me 60. But I'm trying to add to -17, so it's got to be -5 times -12. In other words, I am doing x minus 5 times x minus 12. I've done the slide. I've done the basic factoring, the product sum factoring, and now I need to do the divide. I need to divide both of these values by 5. Simplify if we can, x minus 1. That's what we can do on the left. We cannot on the right, so we kick that denominator up right here and make it 5x minus 12. That is the factored form that we're looking for. And now that we have these two basics down, now that we have these things down, we got 3 forms kind of, right? Now that we've done these, how do we solve using these? And I think that's a great question. So the point of doing all this is to solve. Remember that the solutions are found by setting the function, or what we've got our factored form, equal to 0. Remember, it's ax squared plus bx plus c equals 0. We're trying to get our x-intercepts. We also call those roots. We also call those zeros. And speaking of zeros, we have this thing called the zero product property. It's just a fancy way of saying, if you multiply 2 things together and you get 0 out of it, one of those things, at least one, they could have both, but at least one of those things both have to, or let's try that again. At least one of those things has to be 0. If you multiply 2 things together and you get 0, at least one of those things has to be 0. That's what that says. The zero product property tells you, wow, that didn't work out well. Tells you that if the product of 2 numbers is 0, then one of them must be 0. They could both be, and we're going to do that. In other words, if we factor a quadratic and end up with x plus 3 times x minus 5 equals 0, what would I have to plug into this first one? Just let's look at this guy right here. X plus 3. What would x have to be to make that factor 0? And hopefully you're telling me, well, Mr. Brayman, x would have to be -3, because -3 plus 3 is 0, and 0 times it doesn't matter what the other one is, because 0 times anything is 0. One of those is going to be -3. And if I've got x minus 5, How do I get 0 there? What would x have to be? And x would have to be 5, because 5 minus 5 is 0, and 0 times it doesn't matter what it is over there is 0. The formal way to do this is to set these individually equal to 0 and solve. X plus 3 equals 0, subtract 3 from both sides, and x equals -3. X minus 5 equals 0, x equals 5, because you add 5 to both sides. That's the formal way to do it. Now here we go. We've got 3 practice problems. Remember that it's got to be everything on the same side and equal to 0. Everything on the same side and equal to 0. I'm going to do these 3 problems, and then you've got some practice to work on. Okay, let's do this one. X squared minus 25 equals 0. Does it equal 0? Yes, it does. Can we take a greatest common factor out of x squared and -25? No, we can't. But wait a second. That's interesting. That looks like 2 squares. You know what? This is like x squared minus 5 squared. This is that difference of 2 squares I was telling you about. This ends up being x minus 5 times x plus 5 equals 0. We've arrived at our first major point. We've arrived at our factored form. That's important. Now we need to arrive at our solutions. Either one of these has to be 0 or both have to be 0. In other words, either x minus 5 has to equal 0 or x plus 5 would have to be 0. In other words, x equals +5 or x equals -5. Those are my solutions, 5 and -5. That's that first one. That second one, part B, says x squared minus x equals 12. Step number 1, does it equal 0? No, that does not equal 0. We need to subtract 12 from both sides first. We need to have x squared minus x minus 12 equals 0. Now it equals 0. Now we can look to see what we can do. Is it just 2 terms and they're both squares? No. So we can't use difference of 2 squares. Is it just 1 times x squared? Yeah, it is, in fact. This is our product sum factoring. What multiplies to -12, but adds to, again, think of this as -1 because it is. What multiplies to -1, try that again. What multiplies to -12, but adds to -1? What multiplies to -12 and adds to -1? Well, if it's multiplying to a negative number, one has to be positive, one has to be negative, because that's how multiplication works with 2 numbers. And what's one number apart that multiplies to 12? Hey, 4 and 3. Well, what would have to be negative? Because we're adding to -1. Hey, this would end up being x minus 4 times x plus 3, because -4 times 3 multiplies to -12, and -4 plus 3 is -1. Okay, so this is our factored form. Again, this is important. This is just as important as the solutions. Now we can do this. Now we can set each factor equal to 0 and solve. Whoa. In other words, x would be 4 and -3 for this guy. Interesting. What's our last one say? Well, let's take a look. Number 1, does this equal 0? Does 3x squared plus 2x minus 21 equal 0? Yes, it is set equal to 0. Let's solve for 0. Number 2, is there a greatest common factor between 3x squared, 2x, and -21? No, we're not pulling a greatest common factor out. We are not going to do that. But a is not 1. A is 3. It's 3 times x squared. We got to use that slide and divide. I like it a lot. Let's go ahead and slide this thing over. 3 times -20. In other words, we're going to get x squared plus 2x minus 63 equals 0. I'm going to say to myself, self, what multiplies to negative 63 but adds to 2? And those numbers got to be kind of close together if they just add to positive 2, because one's positive and one's negative. And knowing my multiplication like I do, I know that 9 and 7 multiply to 63. Multiply to negative 63. Oh, they're just 2 apart. So what if I had positive 9, x plus 9, times x minus 7? Because 9 times negative 7 is negative 63, and 9 plus negative 7 is 2. I like this one. So we've done the slide. We've done our product sum or basic factoring. Now we need to do the divide. What did we slide over there? We slid a 3. Divide each of these by 3 and then simplify. Can 9/3 be simplified? Absolutely can. X plus 3. Can negative 7/3 be simplified? It absolutely cannot. So kick that denominator up. 3x minus 7 equals 0. We have our factored form, our FF, our factored form. And now we can take each of those individual factors, set them equal to 0 and solve. I have x plus 3 equals 0. So x would equal negative 3. Or I can have 3x minus 7 equals 0. Add 7 to both sides. 3x equals 7. Divide both by 3. And x equals 7/3. There we go. Our solutions are negative 3 and 7/3. And I love this part at the bottom. It says you can graph these functions in your calculator or Desmos and indeed see that the solutions are the x-intercepts of the graph. I promise you that if you went and graphed all 3 of these, you would find our solutions to be very, very valid. All right, with that said, it's time to move on to practice 1 to get some practice in. Don't forget, make sure it's equal to 0, number 1. Number 2, greatest common factor. Pull that out if you need to. Number 3, determine which kind of factoring you're going to do. Are you going to do the difference of 2 squares? Are you going to do product sum or basic factoring? Or are you going to need slide and divide? All right, ask some good questions when you have them. Some of those practice ones, those first ones are just going to be, it's already in factored form and you need to solve. You just need to find the solutions. So with that said, take care. Have a great day. You stay awesome.